In this video, I am going to discuss assignment problem using Hungarian algorithm. Here, the question is solve the following assignment problem. Here some 5 jobs and 5 persons is given. We have to find the optimum assignment schedule. First step, we have to check the balanced condition. For that, we have to check the number of rows is equal to number of columns or not. Here 5 jobs given and 5 persons given. So both are equal and we can say that the problem is a balanced one. Here number of rows is equal to 5. Number of columns is equal to 5. Here the number of rows is equal to number of columns. So the problem is a balanced one. Next step, we have to go for row reduction. For row reduction, we have to identify the minimum value from each row. First row least number is 5. Second row the least number is 7. Third row the least number is 4. Fourth row the least number is 3. Fifth row the least number is 4. Select the least number from each row and subtract it with all the element in that row. That is, the first row the minimum element is 5. With this you subtract all the elements in the first row. That is 7 minus 5 is 2. 5 minus 5 0. 9 minus 5 is 4. 8 minus 5 is 3. 11 minus 5 is 6. Second row the minimum number is 7. That is 9 minus 7 is 2. 12 minus 7 is 5. 7 minus 7 0. 11 minus 7 is 4. 10 minus 7 is 3. Third row the least number is 4. With this you subtract all the elements. 8 minus 4 is 4. 5 minus 4 is 1. 4 minus 4 is 0. 6 minus 4 is 2. 9 minus 4 is 5. For the fourth row, minimum element is 3. With this you subtract all the elements. That is 7 minus 3 is 4. 3 minus 3 is 0. 6 minus 3 is 3. 9 minus 3 is 6. 5 minus 3 is 2. The fifth row least element is 4. With this you subtract all the elements. 4 minus 4 is 0. 6 minus 4 is 2. 7 minus 4 is 3. 5 minus 4 is 1. 11 minus 4 is 7. Row reduction is over. Third step, column reduction. In the reduced matrix, select the least element from each column and subtract it from all the elements in that column. This is the reduced matrix from row reduction. From that we can pick the minimum value from each column. The first column 0 is the least number. Second column 0 is the least number. Third column 0 is the least number. Fourth column the least number is 1. And fifth column the least number is 2. Now with the minimum element you subtract all the elements in that column. First column 0 is the minimum number. So there is no change in values. 2, 2 again, 4, 4, 0. Second column 0 is the least element. So write the values as it is 0, 5, 1, 0, 2. Third column 0 is the least number. So there is no change in values 4, 0, 0, 3, 3. Fourth column 1 is the least number. So you subtract 3 minus 1 is 2. 4 minus 1 is 3. 2 minus 1 is 1. 6 minus 1 is 5. 1 minus 1 is 0. The fifth column, the least number is 2. That is 6 minus 2 is 4. 3 minus 2 is 1. 5 minus 2 is 3. 2 minus 2 is 0. 7 minus 2 is 5. In this way, we have to perform column reduction. After row reduction and column reduction, we have to find the assignment. For finding the assignment, we have to go for row scanning first. That is, in the first row, you check the 0 values. If you have 1 0 means you square that value. If you have more than 1 0 means you skip that row. So in the first row we have only 1 0. So I mark square for that. After that, you have to draw a vertical line passing through that 0. Now we have to go to the next row. In the next row, you have only one 0. So, you put a square for that and immediately you have to draw a vertical line passing through that 0. Third row, 0 is not there. Fourth row, you have only one 0. You put a square and you have to draw a vertical line passing through that 0. Fifth row, you have two zeros. If you have one 0 means you have mark a square. Here we have two zeros, so you have to skip that row. After row scanning, you have to check all the zeros are covered with the lines. Here, these two zeros are not covered with the lines, so we have to go for column scanning. In the first column, you have only one 0, so you put a square on it. Once you put a square, you have to draw a horizontal line passing through that 0. There is no zeros in that column. After row scanning and column scanning, you have to check number of rows is equal to number of squares marked. Here we have 4 assignments and 5 rows. Number of rows is 5. This is not equal to number of square marked, that is 4. Since number of rows not equal to number of squares marked, we can say that the current assignment is not optimal. If the number of rows not equal to number of squares marked, then the current assignment is not optimal. To get the new cost matrix, we have to follow some procedures. Select the minimum element from the uncovered portion. That is, the element not covered by lines. Subtract this minimum value with the uncovered elements. Adding this minimum value with the values covered by 2 lines. And you write the other element as it is. That is the elements covered by 1 line. If you perform this operation, you will get a new matrix. With the new matrix, you have to check the assignment. Repeat the procedure till you get the optimum solution. Here, the current solution is not optimal. So, we have to find a new cost matrix to get the optimum assignment. For that, the first step, you have to select the minimum element from the uncovered portion. These are the uncovered portions. So, the minimum element is 1. With the minimum element 1, you subtract all the uncovered elements. And you have to add with the intersecting areas. And you write the other elements as it is. Let me repeat. If you have no line means you have to subtract this minimum value. If you have 2 lines means you have to add the minimum value. If you have 1 line means no change. The new cost matrix is 1 is the minimum element. With this I subtract the elements. That is 2 minus 1 is 1. 2 minus 1 is 1. 4 minus 1 is 3. 4 minus 1 is 3. And 0 is covered with a single line, so you write as it is. The next one, this 0 is covered with single line, write as it is. 5 is covered with a single line, write as it is. 1 is covered with a single line, write as it is. 0 is covered with a single line, write as it is. Next one, 2 is covered with 2 lines, so 2 plus 1 is 3. You have to add this with the minimum value. And the third column, 4 is covered with a single line, 0 is covered with a single line, 0 is covered with a single line, and 3 is covered with a single line. And the next 3 is covered with 2 lines. So, 3 plus 1 is 4. And fourth column, 2 is not covered with any element. So, 2 minus 1 is 1. 3 minus 1 is 2. 1 minus 1 is 0. 5 minus 1 is 4. And 0 is covered with a single line. So, you write as it is. Now, the last column, 4 is covered with a single line, write as it is. 1 is covered with a single line, write as it is. 3 is covered with a single line, so write as it is. 0 is covered with a single line, so you write as it is. 5 is covered with a double line, so 5 plus 1 is equal to 6. We have to find the assignment with a new cost matrix. For that, you have to perform row scanning first. The row scanning, the first row you have only 1 0, so you put a square mark. Once you put a square mark, you have to draw a vertical line passing through that 0. Now in the second row you have only 1 0, so you put a square mark and you have to draw a vertical line passing through that 0. Now third row you have only 1 0, so you put a square on it and you have to draw a vertical line passing through that 0. Now fourth row you have only 1 0, you put a square and you have to draw a vertical line passing through that 0. The fifth row you have only 1 0, so you put a square on it and you have to draw a vertical line passing through that 0. After row scanning, you have to check all the zeros are covered with lines. Here all the zeros are covered with lines. So you have to stop the procedure and you have to check number of rows is equal to number of squares marked or not. Here the number of rows is equal to 5. The number of assignments 1, 2, 3, 4, 5. Both are equal. So the current assignment is optimal. Here number of rows is equal to 5 and number of squares marked is equal to 5. Both are equal. So we can say that the current assignment is optimal. After find the assignment, we have to find the optimum assignment schedule and the minimum processing time. Here we have 5 jobs. J1, J2, J3, J4, J5. First job assigned to a person B. Second job assigned to person C. Third job assigned to person D. Fourth job assigned to person E. And the fifth job assigned to person A. Let me write. First job assigned to person B. Second job assigned to person C. Third job assigned to person D. Fourth job assigned to person E. The fifth job assigned to person A. Job 1 assigned to person B. Job 2 assigned to person C. Job 3 assigned to person D. Job 4 assigned to person E. And job 5 assigned to person A. Job 1 is assigned to person B, the processing time is 5. Job 2 assigned to person C, the processing time is 7. Job 3 assigned to person D, the processing time is 6. Fourth job assigned to person E, the processing time is 5. Fifth job assigned to a person A, the processing time is 4. Total value is 27 hours. The minimum processing time to complete the task is 27 hours. The optimum assignment schedule is J1 to B, J2 to C, J3 to D, J4 to E, and J5 to A. The minimum processing time to complete the task is 27 hours. In this way, you have to find the optimum assignment schedule and the minimum processing time. Hope you all understand. Thank you for watching.